Hey everyone, today we're going to build something absolutely incredible. A fully functioning AI-powered shopping assistant that can actually help customers find products in real time. Now, I know what you're thinking, another chatbot tutorial, but this isn't just any chatbot. We're building an AI agent using LangGraph that actually takes autonomous actions. In fact, here's what makes it special. It will autonomously decide when to search the database versus when to respond directly, use custom tools to actively search through real product data, maintain conversational memory and adapt to failures, take multi-step actions such as perceiving, planning, acting, and responding. My name is Daniel Kubo, and I'm a software developer as well as course creator on freeCodeCamp as well as my own channel. And in this course, we'll be using some cutting-edge technologies to build our agentic e-commerce chat assistant. We will use LangGraph from LangChain for agent orchestration, MongoDB Atlas for vector search and to persist the agent's memory, and Google's Gemini as the brain of the agent. Don't worry if you're not familiar with any of these at all, I'll explain everything step by step. By the end of this tutorial, you would have built three main components: a Node.js backend with an intelligent AI agent with memory, a MongoDB database populated with AI-generated product data, and a React frontend with a beautiful chat widget that your customers will actually want to use. And the coolest part? Unlike traditional chatbots that give pre-programmed responses, our AI agent actually thinks and acts like a human sales associate. It autonomously decides whether to search the inventory, chooses the best search strategy, and can even adapt when things go wrong, like falling back from vector search to text search. This is the future of AI agents that don't just chat, they actually do things. Whether you're building an e-commerce platform, want to learn about AI agents, or just curious about the latest in conversational AI, this tutorial has something for you. So fire up your code editor and let's build the future of customer service together. Okay, so let's do it. First off, I'm just going to start completely from scratch. Here I am in VS Code. Note I am using the free CodeCamp theme. And I've just created a folder called e-commerce chat helper. So please feel free to name yours exactly the same like me, or you can call it whatever you wish. It is really up to you. So e-commerce chat helper. Now we're going to create a Node.js backend. So I'm just going to create a new folder just so we can keep everything separate. I'm going to call it server. And now I'm going to use my terminal to go into the server just like that. So now I'm in here. And what I'm going to do is just do npm init and hit enter. Now we're just going to create a package JSON. I'm going to select the default settings. So package name, server, version 1, description, entry point, test command, git, repository, keywords, author, everything is just default, and click yes. Great. So now in my server, the package JSON should show up. Now we are going to have to install a few things. So we're going to install TypeScript so that we can use it. I'm going to do so simply by running npm install save dev TypeScript at types node. So that will show up in my package JSON as well. Great. So that is everything that is in my server directory right now. And I'm just also going to create an index.ts file. So there we go. And we should probably change that to index.ts2 so it matches. Great. So I'm just going to minimize this for now. Let's go back to our package JSON. So we are going to have to update the script. So I'm just going to delete that. And we're going to have this script that will essentially run our backend. So it's going to run the index.ts file that we just created. In addition to that, we're also going to have a command to seed our database. So seed database is another file that we will create. It's going to seed our MongoDB database. So those are two scripts that we need. I'm just going to go ahead and install some other dependencies that we will be using in this tutorial. Express for routing, MongoDB so we can communicate with our database, CORS to get rid of those pesky CORS messages, LangChain Google Gemini for creating vector embeddings from text using Gemini, LangChain core for various things that we will get into when we import the package and its methods, LangChain LangGraph for essentially using LangGraph from LangChain, LangChain LangGraph checkpoint MongoDB. This is going to be for saving conversation state. Of course, LangChain MongoDB, .env for working with secret variables, LangChain itself, and Zod. Zod, if you haven't heard of it, is a schema validation library. We're also going to have to get types from CORS as we are working in TypeScript, types from Express, and TS Node, just for working with Node in TypeScript. And that should be it. So hit enter. And great. So here you are, all the dependencies. As you can see, the versions are here. If you're watching this in the future and something doesn't work, please revert back to these versions, okay? So just have exactly the same ones that I have here right now, just to avoid any kind of errors that you might come across. Okay, so same versions as this, please. I'm just going to go ahead and move these types to the dev dependencies just because I prefer it that way. So there we go. And same for this one here. Great. So don't forget, you will be able to get this code in the description below. Okay, so this is looking good. Once again, I'm just going to zoom out. Here are all my dev dependencies and my dependencies. We're done with this file now, so I'm just going to shut it down. Okay, now the index.ts file. Okay, so first we're going to load environment variables from the .env file. Of course, we don't have any yet, but I'm going to put that there as we will need to use it. Then we're going to use Express, and we're going to import Express frameworks for creating web servers. So we're going to use Express request and response. And now we're also going to import MongoDB client for database connection. We are also going to be writing a custom AI agent function that we're going to have to import from another file. And now what we can do is create an Express application instance. So we're calling Express, we're saving all of that Express wonderfulness under the const app so that we can use it later. We can use all of its wonderful methods and properties from this const. Before we move on, we're going to actually have to import course middleware. So this is going to help us handle cross-origin requests. And to enable this, so to enable CORS for all routes, we're going to do that. Okay. We're also going to have to enable JSON parsing for incoming requests because we are going to have some incoming requests coming from our front end. Great. So now that we've kind of set this up in this way, I think the first thing we're going to do is create a MongoDB client using connection strings from environment variables. So we're of course going to have to create those environment variables. So process env will help us access anything in the .env file which I'm about to create, and this is going to be my first variable. So I'm simply just going to create a new file, call it .env, and paste MongoDB Atlas URI like so. We are also going to need a Google API key as we are going to be using Gemini, which comes from Google. So those are the two things that we're going to need in here. Let's go sign up to MongoDB now. Okay, so here we are on the MongoDB website. Don't worry, this is free to sign up. You're not going to need your credit card details or anything like that. And I'm simply just going to go ahead and sign in because I have used this before, so you might need to sign up. So that is up to you. I'm just going to show you what the dashboard looks like once you have signed up. So this is essentially what it looks like, and I'm going to talk you through it. Okay, so this is what the dashboard looks like. Here I am. Here's my organization name, which is just Anya, and we're going to create a cluster. Okay, so here we are, deploy your cluster. We're going to go with free, and then you're just going to keep the default configuration. So name, cluster 0, provider, region. Make sure yours is the same as mine, and then click create deployment. So the only thing we're going to be doing is creating a cluster here. Everything else we're going to be doing from the app. By that, I mean we're going to create a collection and a database using the app itself. So great, current IP address not added. So please go ahead and add your current IP address so that you don't get blocked when trying to communicate with your database from your app. So mine has been added, and now we can connect to my application. So you're simply going to go ahead and select this one here and get this connection string. So please go ahead and copy that and paste it here like so. Okay, so there we go. The only thing we're going to have to do is replace the database password. So going back here, I'm just going to click done. Database access. Here I am, username, you're going to edit. I'm just going to go with, I'm just going to show you 123. Okay. And then I'm just going to update the user. So now essentially you do know my username and password, but I will be deleting all of this, deactivating, so I don't really mind sharing with you for now. So Anya123, okay, please go ahead and update yours with your password too, and great. The other thing we're going to need is a Google API key. For this, you're going to head over to console.cloud.google.com. And this is what the page should look like. You're going to go to APIs and services, credentials, and you can create a new one, so new API key, and copy that right here. Okay, so there we go. I'm just going to shut that down for now and just paste in my Google API key. Once again, this will be disabled in the future, so don't go try stealing it. Okay. I'm just going to make this a string. You don't really have to, but you know, each to their own. Okay, so done with this file now, let's continue. So great, we should now be able to connect to the Mongo client as we can access the MongoDB Atlas URI using process.env. Now we're going to write an async function to initialize and start the server. So async function start server. We're going to do try and of course catch any errors. Console error and then the error. So we're just going to put that for now. So what's our start server function going to consist of? This is going to be a long one. We're first going to establish connection to MongoDB Atlas. So we're going to await client connect. So we're just using this right here and getting the method of connect and calling it. Next, we're going to ping MongoDB to verify connection is working. So we're going to do that with this line of code. And then let's just print out a console log, okay, letting us know that we've successfully connected to MongoDB. We're going to be doing a lot of console messages just so we can see everything in the console. And just so also you can debug where you're going wrong and what's not working for you. So great. Now we're going to essentially define the root endpoint. So this is just going to be a simple health check. We're going to send a simple response to confirm the server is running. So I'm simply going to do rest send LangGraph agent server. So this should essentially help us check that the server is running correctly. Okay, so successfully connected to MongoDB, successfully running the server. Now we're going to define an endpoint for starting new conversations. So this is going to be a post request. And we're going to post to chat. And this is essentially going to help us start a new conversation. And to start a new conversation, we're going to extract the user message from the request body. Okay, so we're going to do that with the request body message. So whatever's coming from our front end is being saved with the request body under message. And we're saving it as initial message. So it could be hello chatbot, and that will be saved under initial message. Okay, we're sending that from the front end to the back end. Next, we're going to generate a unique ID. It's going to be a unique thread ID using just the current timestamp, which is why I use date now to string. And that's just going to help us keep each conversation unique. Okay, and once again, I'm just going to console log that initial message so we can see what's going on under the hood. Now I'm going to write another try. And of course, catch, so catch error, console error, error. And this is now going to call our AI agent with the message and new thread ID. So we're going to pass through the client, we're going to pass through the initial message, which we've discussed, and the thread ID, which is unique. And we're going to call the agent with that. We've imported that. We haven't written that yet, but just keep that in mind. Okay, and if this is successful, we're going to send a successful response with the thread ID and AI's response. So we've got our initial message. This is going to get us the response from that AI. Okay, and of course, we are going to log any errors that occur during the agent execution. So we've got an error. You know, for debugging, we could even say the error starting conversation here, string, as well as the error will be shown. And then, of course, we also need a status code. So 500 is the one we're going to use for the error. And internal server error has occurred. Great. So that essentially is all one thing that lives inside this try block. We're going to define another endpoint now, and this endpoint is going to be for continuing existing conversations, okay, which is why it's going to look like this. We're making a post request to the chat, but we're also identifying that chat by its unique identifier, so the thread ID, which we're going to pass through to the URL. Okay, so in order to extract that ID from URL parameters, we're going to use this code. This essentially is using request params. So it's looking at the URL and picking out this so that we can store it as a const here. Next, we're also going to extract the user message from the request body. So this is probably like a follow-up message. So you've gone, hi chatbot, do you have any chairs? And they've responded, so the AI agents responded. And now you're going to want to ask something else. So this is where that happens. You're kind of continuing the chat with the same thread ID. Okay, so once again, another try and catch block. Console, error. This time we're going to call the AI agent with a message and existing thread ID. So it's continuing the conversation like I said. And we're just going to send that response over. No need to send the thread ID again since, it's continuing. We already know that. Okay, great. And of course, let's log in any errors. This time, I guess the error will be an error in the chat itself. So I'm going to put that here just for our debugging and for debugging purposes. And let's send over a status code 2. Once again, it's going to be a 500. Great. So that's another endpoint right there. Okay, so that's all we're going to do. We're going to do 2, essentially to start the chat, so the initial message, and the response to whatever the agent came back with, and continuous responses from then on. Great. Now, this wouldn't be complete without us, of course, defining our port. So the port we're going to use is 8000. We haven't put anything in the .env file, but you might want to. And of course, we're going to listen out to that port, so to port 8000. And we're just going to console log a message. So console log server running on a port 8000, just so we know everything is fine. Phew, so this is looking good. And of course, now we catch any errors to the full thing we just wrote, to the full start server function. And the error is going to be, well, it's going to be an error connecting to MongoDB if this all hasn't worked. So that's going to help us know when this error has occurred. And then we're just going to exit the process with error code 1, okay, indicating failure. Great. So now that we've wrote that whole function, I'm just going to call it with start server, just like that. Wonderful. So we are now done with this file. Essentially, this will start our server like I said. But before we do any of that, let's actually seed our database first with some stuff. So let's do it. I'm just going to close that down for now. So we've got our index.ts file. The next file we're going to work on is the seed database ts file. And like I said, this is going to help us seed the database. So I'm just going to call this seed database ts and hit enter. Now for this, we are going to have to start using Google Gemini, so a bunch of stuff from there, including Chat Google Generative AI and Google Generative AI embeddings. Now, if you don't know what embeddings are, this is quite a long topic, not one for today. I do have a great video on this on the freeCodeCamp channel, so please do search for it. For now, in the quickest way I can describe it is we're going to use embeddings to compare similarity in words or phrases. So for example, if you've got a phrase, a cow jumped over the moon, you're going to turn that into an embedding so that you can compare it against other phrases to figure out if that phrase is similar. So you're going to compare embedding against embedding. Now, what's also important to know is that if you create an embedding using Gemini, you can't compare it to one from OpenAI, for example. So make sure to keep that in mind. So great. Very basic, very nutshell explanation. This is like a 20-minute long video as well, so there really is a lot on this topic. I hope you enjoy it. Let's continue, however. I'm going to put that on 2 lines just so you can see it. The next thing we're going to do is import structured output parser to ensure AI returns data in a specific format. So that's what that is for. And then of course we're going to import a MongoDB client for database connection, just like we did in the previous file. This time, however, we're also going to import MongoDB Atlas vector search for storing and searching embeddings. So that is necessary. And we're going to import Zod for data scheme validation and type safety. One more thing we're going to do is we're going to import .env config just like we did in the previous file so we can get variables from our .env file. Great. So just like we did previously, we're going to create a MongoDB client instance using the connection string from the environment variables so that we can essentially talk to our MongoDB database. Next, we're going to initialize Google's Gemini chat model for generating synthetic furniture data. So in order to do this, I'm just going to define const LLM just like so. And we're going to do new chat Google generative AI, so essentially that. And then we're going to pass through an object. And in this object, we're going to define the model. So for this, I'm going to use Gemini 1.5 Flash. That's the model we're going to use. We're going to also set the temperature, so temperature to be 0.7. So temperature is also kind of like a creativity level. So 0.7 is moderately creative. Now we're also going to pass through the API key. We've already saved that in our env file. So using process env, I'm just going to get it. We've saved it as Google API key. So make sure to spell yours exactly the same like you did from your environment variables. Great, so all of this is going to help us initialize Google Gemini. Okay, so now we're going to define a schema just like so. So using Zod, we're going to do .object, and then I'm going to pass through an object. So this is essentially what I want my fake furniture to consist of. So each fake furniture is going to have a unique item ID, which is going to be a string. We're of course going to name it something. So let's pass through an item name, a description, which is also going to be a string for my fake furniture, the brand name of my fake furniture, the manufacturer address. So this in itself is going to be an object. I'm making this kind of complicated just so you know how to work with complicated objects and can essentially, change this to whatever you need. So we've got street, city, state. Let's have postal code and also country. Okay, now same with prices, that's going to be an object because I think, most things in these kind of databases would have more than one price. They would probably have the full price. Okay, so let's have the full price. This is going to be a number. And the sale price as well. So sale price goes here. Great. We're also going to have an array. I told you this is going to be a great one for you because you can really adapt this as you want. So we're also going to be working with arrays, and this is just going to be an array of category tags that it belongs to. So maybe like cookie or antique or something like that. We're also going to have user reviews. So this is, again, an array, but this time an array of an object that we're going to define. So Z object. So these objects make up our user reviews. And it's going to have the review date, the rating, and the comment. And wonderful. And the last thing I'm going to do is just add additional notes about the item because, that's a nice thing to have. So let's just do that at the end. So wonderful. We are now done. Let's move on. Now we're going to create a TypeScript type from Zod schema for type safety. So essentially the item schema that we just wrote, I'm going to create a TypeScript type for that. It's just called item. Now we're going to create a parser that ensures AI output matches our item schema. So that is the code to do that. Great. I think let's move on. Okay, so this time we're going to write a function to actually create a database and collection before seeding our database. So like I said, we're going to be creating everything in MongoDB from this project. In order to do that, we're going to write an async function just like this. It's going to be called setup database and collection. And we're going to just send out a console log to start. The console log is going to say setting up database and collection, just so we know that we've hit this point. And then we're going to create a reference to our database. So I'm just going to call it inventory database and store it under the const db. Next, we're going to create the items collection. If it doesn't exist, it's always good to check if it exists previously. And we're simply going to do that. So we're going to go into the database, which of course we haven't created yet, list the collections, and we're going to look for a collection called items. Okay, so by now you know that we're calling our database inventory database, and our collection is called items that lives inside the inventory database, which we haven't made yet. None of this is made yet. Okay, so great. So we're checking if a collection exists in the inventory database by essentially listing the collection, finding the collection called items, and saving it under collections. So if collections length essentially equals 0, we know we're good to go. So we're going to create the collection, and we do so with that. And then we can just console log it out. So I'm going to do console log created items collection in the inventory database. Great. Else, so if we already have something in there that we forgot about, I'm just going to console log items collection already exists in the inventory database. Great. So that is our whole async function called setup database and collection. Let's move on. Now we're going to write another function. So there's another async function. It's going to be called create vector search index promise void. We're going to do another try and catch. So catch error console error. And what we're going to do is essentially try and create the vector index, but for that we need to define the database. So there we go. We need to define the collection as well, and then we need to await collection and drop indexes, so if anything exists. Now let's actually define the vector search ID. So I'm going to go const vector search ID x. And then we're going to just name the vector search ID. We're going to define the types. Of course, it's a vector search. And then we're going to do the definition. So just like that, definition. And I'm just going to paste this in to make sure yours is exactly the same as mine. So after that, we're just going to do another console log. So console log creating vector search index. And then we're going to await the create search index by passing through that vector search ID that we just defined. And eventually, once that is done, we're going to console log successfully created vector search index. So we're assuming that was a success. Great. And of course, if it wasn't, I'm just going to put the error of fail to create vector search index and show the error. Wonderful. So that's it for setting up everything for the MongoDB database to start receiving furniture. So let's generate some furniture. So I'm just going to scroll down because we're going to write yet another function. So async function generate synthetic data promise void. Okay, so we're going to just essentially define a prompt that is going to instruct AI to generate furniture stored data. So here it is. I'm just going to put that on a few lines here so you can see everything and copy mine. So it's exactly the same. So you are a helpful assistant that generates furniture store item data. Generate 10 furniture store items. Each record should include the following fields. So item ID, item name, item description, brand, manufacturer, address, prices, categories, reviews, and notes. So everything we wrote in the schema before. Ensure variety in the data and realistic values. And then we're just going to add format instructions from the parser. So we're going to pass that in too and put in a backtick like so. So closing that one right there. So that one and that one should match. So we have our prompt. I'm just going to console log the progress. So console log generating synthetic data because that's going to take a while. Okay, so then we're going to send prompt to AI and get the response. And once the response comes back, we're going to pass it into a structured array of item objects using this code right here. Great. And now because this will be an array, we can update this so it's not void and it's actually an array of items that we defined previously. So just make sure to change that like so. Wonderful. So that's really it. Let's move on. Now we're going to write another function, async function. And this is going to be a function to create a searchable text summary from the furniture item data. So I'm going to call it create item summary. It's going to take items and then it's use the schema. And then it's just going to return actually just a string. And okay, so we're actually going to return a promise for async compatibility. So I'm just going to pass through resolve. And first off, we're going to extract manufacturer country information. So from our fake data, we're going to get manufacturer details. So the string of made in with backticks and item manufacturer address country. So this is the made up items manufacturer address and country. Next, we're going to join all the categories into a comma separated string. So this is all helping us write an item summary. And next, we're going to convert all user reviews into an array in a readable text format. So all I'm going to do is get the item user reviews and then map. And for each review, using backticks, I'm in fact going to put this on a new line so it's easier for us to read. I'm going to say rated 5 for whatever it made up on this review date with this review comment. Great. And I'm just going to join the multiple reviews with spaces using .join. So again, just put that on a new line. Now we're going to create basic item information as a string. So once again, just using that fake data that I created, I'm going to get the item name, the item description. So it's going to say item name, item description from the brand and the brand name, and that's going to make up our basic info. We're of course going to do the same for the price. So let's do it. Const price. I'm just going to put it on 2 lines. At full price, it costs for price USD. On sale, it costs this sale price. And last one, we've got notes, right? So I'm just going to save that as notes. Very simple item notes. So once we have all of that, I'm going to combine it all to create a lovely comprehensive summary for vector search. Okay, so here's our summary: basic info, manufacturer details, categories, reviews, price, notes, you guessed it. Okay, wonderful. So once we have our summary, I'm going to resolve and pass through the summary like so. So great. I hope that makes sense. That is the whole async function right there. Beautiful. So once we've created a little summary for our database, I think it's time to actually see the database. So async function seed database promise void. Once again, try catch error console error, the actual error. And what we're going to do is, of course, establish a connection to MongoDB, ping the database to verify everything works, and then just console log it so we know what's going on. So console log, you've successfully connected to MongoDB. Now we're going to set up a database and collection. So we can use that async function to set up the database and collection. Then we create the vector search index. So all the functions that we just wrote are going to go in here eventually. Okay. Once we've done that, I'm going to define the database again. So there we go, inventory database. Define the collection again. And clear existing data if there's anything in the collection. I'm just going to console log cleared existing data from items collection. And now we're going to generate new synthetic furniture data using AI. So this is the last function that we're going to put in here that we wrote, await generate synthetic data. Great. So we've got that data. Now we're going to process each item and create a summary and prepare for vector storage. So const records with const records with summaries await promise all synthetic data map async record and an object page content await create item summary record. So that creates searchable summaries, and then we're going to add metadata and then preserve the original item data as well using this. Okay, cool, nearly done. Now we're going to store each record with vector embeddings in MongoDB. So we're going to loop for this const record of records with summaries await MongoDB Atlas vector search. So we imported that, and we're going to get from documents, so a method from it. And this is going to essentially create vector embeddings and store them in MongoDB Atlas using Gemini. So we're going to pass through the record, and then we're going to need the Google generative AI embeddings that we also imported, and just set our API key process env Google API key and the model name. And we're going to use text embedding 004. Okay. So this is just Google's standard embedding model, 768 dimensions. So that's going to be important later. Wonderful. Just make sure that is a curly brace right there, and so is that one. Now we're just going to put in another object. So just like that, we'll pass through the collection, so the MongoDB collection reference, the index name, which is going to be vector index, the text key. I'm going to do embedding text, so this is just the field name for the searchable text, and embedding key. which is going to be embedding. This is just the field name for the vector embeddings. Okay, just correct that. And now I'm just going to log the process of each individual successfully processed item. So there we go. Okay, so that is it. It's quite a long one, so you might want to refer to the documentation for this. Hopefully I explained everything well. And once that is done, so outside of here, console log database seeding completed. I'm just going to move out a little bit so you can see again. So this is the whole async function, seed database, try all of this, and then catch error. And if this is an error, it's going to be an error in seeding the database. So I'm just going to add that. And this time, I'm just going to add one more thing. So let's just zoom in a bit. Finally, await client close. Great. So now we can actually call that function seed database and catch any console error. Now, before moving on, I need to create a tsconfig JSON file. So I'm just going to hit that command, making sure I am in the server. So great. Here we go. This is what yours should look like. I'm just going to delete everything that is unnecessary. So just like that. So that by the end, you should have that in there. We are also going to add tsnode transfile only true. So great. Now that that is done, let's seed our database. So all I'm going to do is just get up my terminal, make sure I am in the server, and do npm run seed, just like so. Okay, and great. Here we see all our console logs. You have successfully connected to MongoDB, setting up database and collection. Items collection already exists. Creating vector search index, successfully created a vector search index, cleared existing data from items collection, and generating synthetic data. So this is going to generate our 10 items, and we have a record of each one. So this is looking good. Once this is finished, we'll head over to MongoDB to see if this has worked. Great. Database seeding completed. So now under clusters, if I click into cluster 0 and I go into collections, you should see our database, which is inventory database, and our items, and there is 10 indeed. So here we go, we get a modern sofa, comfortable and stylish sofa with plush cushions, brand furnish max, the manufacturer address, which is an object, the price, which is an object where you get the full price and the sale price, the categories, the user reviews, which is one in here, there's an object, we got a 4.5, and some notes. Great, so we did it. We have successfully seeded our database. If you ran into any errors, like I said, the code will be available for you so you can check it out and see where you went wrong. Okay, so let's continue. This is wonderful. We've seeded our database. I'm just going to minimize that. The next thing we're going to do is create our agent.ts file. So I'm just going to create an agent.ts just like that. Make sure agent is in here. Okay, great and wonderful. Okay, so a bunch more imports here that we're going to need. We're going to import Google Generative AI embeddings from LangChain Google Gen AI. We're going to also get Chat Google Generative AI. So that is another one that we're going to get from the same place. We're also going to import AI message, base message, and human message from LangChain core messages. These are message types for conversations. We're also going to import chat prompt template and message placeholder from LangChain core prompts. It's going to help us create structured prompts with placeholders. We're going to import state graph from LangChain LangGraph, as well as annotation, which is just annotation types. And state graph is going to help us with state-based workflow orchestration. We're also going to import tools. This is going to help us create custom tools, as well as pre-built node for executing tools. So here, this is what it looks like. Next, we're going to import MongoDB Saver for saving conversation state. We're also going to import vector search integration with MongoDB using this import right here, as well as import the MongoDB database client Zod for schema validation once more. And once again, we're going to load environment variables from the .env file thanks to this right here. Great. Now let's write an async function called retry with back off. This is going to be a utility function to handle API rate limits with exponential backoff. And then we're going to pass through the function to retry, as well as define the max number of retries. So I'm just going to put 3. And then we're going to say that for each retry attempt, so let's actually loop through them for let attempt equals 1, attempt max retries, attempt increment by 1. We're going to try and of course catch any errors, console error, error. Well, we're just going to try to execute the function, okay? Now, if there are any errors, so if the error status is exactly 429, let's say, and we still have attempts left, so smaller than max retries, then we're going to calculate the exponential backoff delay. And then let's just put a console error in here. So let's put the error message in here. And let's just throw something that says rate limit hit, retrying in XXX seconds. Okay? And then we're going to wait for the calculated delay before retrying. So this is just something so we can keep trying until it works. And then we're going to continue. Great. And then throw error. So basically, if we haven't hit the rate limit, but we've run out of retries, throw the error. Okay? And then we just throw the error here too. So throw new, and then we're going to pass through a message, max retries exceeded. Wonderful. Okay, so that's our retry function, just in case we need to do that. Now let's actually write the main function. So the main function that I'm going to write, I'm going to export this. It's an async function again. We're exporting it as we want to use it in the index.ts file. And we're going to call this call agent. And what we're going to do is essentially create a function that creates and runs the AI agent. So we're going to pass through, if you remember from the index.ts file, the client. And then we have a type for this. It's a Mongo client that we imported. The query, which is going to be a string. And the thread ID, which is also going to be a string. Cool. So that is our function. Now let's write it. So once again, well, let's do try catch any error, console error, error. And once again, let's define the database. Let's get the database instance. Let's get the items collection, because we have that now. We've created it. And now let's define the state structure for the agent workflow. So const graph state equals annotation root messages, and then we use the annotation here, base message type, and that is an array. And now let's write a reducer to help us combine old and new messages. So we're simply going to concatenate old messages X with the new messages Y. Great. Now we're going to create a custom tool for searching furniture inventory. So I'm going to call this const item look up tool. I'm just going to move this down here. So tool, which we have imported from above, and the actual function that we executed is going to be async. It's an async function, and I'm just going to pass through the query like so. And we're going to have 10 items to look through because that's how many we created. And we're going to do try. And then we're just going to console log this out so we know what we're doing under the hood. Console log item lookup to called with query, and then the query that we pass through. We're going to check if the database has any data at all using this. And then we're going to console log the total documents in the collection. Okay, great. Now, if the database is empty, so if total count equals 0, we're just going to let us know that the collection is empty. And then we're going to return this object. So error, no items found in inventory, message the inventory database appears to be empty, and count 0. Great. Now let's get sample documents for debugging purposes. So this is how you would do that. We're going to go into the collection and find 3. And these are going to be our sample docs. So let's go ahead and see them too, again, for debugging purposes. Now, once that is done, we can actually go ahead and configure for MongoDB Atlas vector search. So in order to do this, let's define our database config. It's essentially going to take the collection, which we have defined above, the index name, which we have defined as vector index, the text key. So again, just the same as we did before, embedding text. So that's the field containing the text used for embeddings. Make sure yours is the same as in the other file. Embedding key, again, make sure this one is the same. Okay, so the field name has to be the same in both files. Great. Now that we have defined the config, we're going to create a vector store instance for semantic search using Google Gemini embeddings. So in order to do this, let's define our vector store, new MongoDB Atlas vector search. So we imported that from above, and we're going to also create a new Google generative AI embeddings. So again, we imported that above. And we're going to have to pass through the API key to use it. So we have that stored in our process env file as Google API key. And also pass through the model. It has to be the same one as we used before. So once again, make sure that this is the same, the other file too. So the index.ts file. Wonderful. And then, of course, we pass through the db config as well. Great. Just make sure this is Atlas like that. OK, so once we've done that, let's just, again, do a console log to check everything is working as it should when we debug. So performing vector search. And then we're going to perform semantic search using the vector embeddings. So we're going to await the vector store and do a similarity search with score. We're going to pass through the query. So whatever question we asked it, like, hi, chatbot, will be passed through in here. And then it's going to search our database. So if we said, hi, chatbot, do you have any chairs? It's going to search our database and return back some results. OK, so this result will be the literal result that we see in the database. So for example, it will just bring back this. No, we want it to be in a human readable kind of response. So we're going to have to use some more AI for that. But first, let's write some fallback code just in case vector search return no results at all. So if results length equals 0, console log vector search return the results, try text search. So this will literally do a text search using regular expressions as a backup. Okay, so for some reason it didn't work. I'm not sure why. Const text results, we're going to look for it with regex instead in our MongoDB database. So this time we're going to use await collection find object, and I'm going to paste this so I don't make any mistakes. Okay, there we go. Okay, so you're essentially passing through an OR condition that matches any of these fields. So this is case sensitive search in the item name, the description, the categories, and the embedded text. Great. And then we're just going to do dot limit pass through n to array. Wonderful. So if that works instead, we're just going to console log out text search returned and the text result length results. Let's make that plural as that is more accurate. Great. And now we're going to actually return, so return JSON, because that's just console logging it out, stringify the results. And then we're just going to put through the text results. The search type will define as text as a string. The query, we're going to return the query, and the count, so how many items came back. Text results length. Wonderful. Okay, so that is it. However, of course, we do want the vector search, so if we did get the vector search results coming back, we're going to return them back as JSON as well. JSON stringify results, the actual result, search type vector, so we don't get confused. And then again, the query and the count, this time of the result length. Great. So this is looking good. I'm just going to delete the space, and we're going to catch any error. Okay. So if there was an error in item lookup, we want to see, and we also want to see the error details. Great. We can also, of course, return the error as a JSON string, so stringify error, failed to search inventory, details, error message, and the query. Wonderful. So this is looking really, really good. Great. Now we're going to define the metadata for the tool and the schema definition. So name, item, lookup. This is the tool name that the AI will reference. We're going to put in a description as well. I'm just going to put the description of gathers furniture item details from the inventory database. We're also going to have a schema. So schema. This is going to be an object. It's going to, of course, take the query, which is going to be a string, and we're going to describe it. We're also going to put n here because that's what we also pass through, and that is going to be a number. It's going to be optional, and the default is going to be 10, and the description of it is going to be number of results to return. Wonderful. Okay. Now we're going to write an array of all available tools. Essentially, it's just one in this case, but if you want to add more, you can. Okay, and now this means we can create a tool execution node for the workflow, and you simply do it like that. Great, now that we've done that, let's initialize the AI model, so Google Gemini, in order to get actual human-like responses. So once again, let's define the model, new chat Google generative AI. It's an object. We're going to define the model again, the temperature. So this time it's deterministic response, no randomness. The max entries we're going to put as 0 because we handle our own. We're going to put in the Google API key, and we're going to bind our custom tools to the model. Great. Now it's time to write the decision function, which determines next steps in the workflow. So I'm going to call this function should continue, just like so. We'll pass through the state type of graph state. We'll get all the messages. We'll then get the most recent messages. And if the AI wants to use tools, go to the tools node, otherwise we'll end. So if last message dot tool calls exists, get its length. So if that exists, we'll return tools, otherwise we will end. Great. Now time to write another function. So this is an async function called call model, and this function will call the AI model with retry logic. So let's put state type of graph state. We'll return retry with backoff async. So we're essentially wrapping this in retry logic before creating a structured prompt template. So let's define our prompt. I'm going to use chat prompt template dot from messages, and then let's create an array. It should say system, and then let's put in the prompt. So I'm going to paste it. It is in backticks. Apologies, it is very long, so there you go. Once again, it is in backticks. Please do take it from the project provided. If you are not sure, if you cannot pause here. If you are pausing here, please take a moment and unpause when you're ready. Let's continue. Okay, so once you are ready, you're just going to put a placeholder for conversational history right in here. Great, wonderful. Now after this right here, we're going to fill in the prompt template with actual values. So const formatted prompt equals await prompt dot format messages. We'll put in the current timestamp. We'll pass through the messages, and then we're going to call the AI model with the formatted prompt and return the new state with the AI's responses added. Wonderful. We are nearly there. We now need to build the workflow graph. So const workflow equals new state graph. We're going to pass through the graph state just like so. I'm going to add a node agent call model, which will add the AI model node. We're going to add the tool execution node. We're going to start workflow at agent. We're going to then let the agent decide tools or end, and then after tools, we'll go back to the agent. So that is the workflow that we have defined, which now allows us to initialize conversation state persistence. So here we go, that's what we're going to do. And then we're going to compile the workflow with state saving. So we'll check this works later as well. We'll check that check pointer. Now that we have done that, we can actually execute the workflow. So const final state equals await app invoke messages, and then pass to an array, and then the new human message. So we're going to start with the user's question and pass it through the new human message, and we're going to prevent infinite loops. So I'm just going to create another object there and pass through a recursion limit, and also pass through the conversation thread identifier. So just like that. Wonderful. This means we can now extract the final response from the conversation. So you can do so with this line of code. And I'm just going to console log out the agent's response to our question as well. And we're just going to return the response. Great. Okay, so now we'll just deal with any errors that this could have run into, and there could be a lot. So I think let's just console log error in core agent and then the error message. And if the error status equals 429, so that is a rate limit error, I want to throw a new error that says service temporarily unavailable due to rate limits. Please try again in a minute. Okay, so that's what we're going to do. Else, if error status equals 401, so this is an authentication error, we're going to put authentication failed. Please check your API configuration. So we really know what is going on. Else, and then we just have a default, which is going to throw an error that says agent failed and the error message. Okay, so this is looking wonderful. Let's give it a whirl before starting our front end. Now, in order to do this, we need to actually start the backend. So make sure you are on the server and do npm run dev. Okay, so we are now running the server. Let's create a new terminal, and I'm just going to do curl post message. So we're sending a message through to the endpoint chat, and our message is going to be, do you have any dining tables? We're pretending to be someone on a website, and let's see what our agent says. Now you might get an internal server error if here it does tell you that the model is overloaded. Please try again later. It could just be a busy time and you might have to come back to this. Otherwise, everything should be okay and you should get this back. Great, so this is working as it should. Let's now build out our front end. Let's do it. Okay, so I'm going to minimize the server as we are done with that, and I'm going to create a client directory. Now in here, what I am going to do is create a new terminal, and I'm going to go into the client, and I'm just going to create a React project. It's going to be a super basic one, so create React app and dot in order to create a React project in this directory. So the package.json file has been created. It's just going to spin up all the other files for me super quick. And great, now I'm just going to do npm run start in order to start the front end. So this will get started on localhost 3000. My backend is on localhost 8000. So now we have both set up. Let's get rid of this default for now. So in the source directory, I'm going to make this super simple. We're not going to have any tests, so I'm just going to delete that. We're not going to report web vitals either, so let's delete these two. I'm just going to delete those and move them to trash. We're also just going to get rid of any styling for now, so get rid of that. Let's get rid of this code, okay? And then in the app.js file, we're not going to import the logo, and we're going to delete all of this and simply return a wrapping div, which is going to have the class name of app, and then an e-commerce store component. Okay, so we're going to make that and import that in here too. So import e-commerce store from, and we're going to put it in components, so a folder called components, and of course it's just going to be called e-commerce store. So let's go ahead and create that. I'm going to create another directory called components, and in here a file called ecommercestore.js. Okay, we're going to do it in JavaScript, as we're not going to be so super strict with TypeScript for now. You can do if you want. Okay, so once again, this is everything in the index.css file. This is everything in the app.js file, nothing in the app.css file, and we've created an e-commerce store component. We're going to also import into here some icons from a React icon file. I'm just going to minimize this for now. So that is something we're going to have to import. And we're going to also import chat widget from another file called chat widget. So this is another component which we are yet to create. So I'm going to comment that out for now. So let's create our e-commerce store, shall we? There we go. And we're going to do export default e-commerce store, making sure to spell it exactly the same. So what are we going to return? Well, we're just going to return like a basic website. We're going to have a header element. So maybe let's give this the class name of header. If you want to pick it out by class names, it really is up to you. I'm going to create a div, and this is going to have the class name of container. I'm going to create another div, this time with the class name of top bar, and then we're going to have a div, and this is going to say shop smart, and the class name of this is going to be logo, as this is going to be our shop logo. We're then going to also create another div. This is going to have the class name of search bar, search bar, just like so, and then we're going to put in the input. For this, it's going to be the type of text, even though that is the default, and the placeholder text. Next, we're going to put in a button, just like so, and in it, a search icon from React Icons. Great, now let's move on to the nav icons. So create a div once more. I'm going to give this the class name of nav icons. We're going to use an A tag for this with an href that isn't really going to go anywhere. It's just going to take us to a link on the page. So hash to account. We're going to look for the ID of account and go to that element. Okay, next, I'm just going to put in a var user from the React icon input. Great, with a size of 20. Now I'm going to repeat these, so I'm going to have another A tag, just like that, with an href. This time, this is going to say wish list. This is going to have var heart size 20. And this one is also going to have a span. This is going to show us how many hearts we have. So I'm just going to put in 3. Like so, and also give this a class name. So class name of badge, so we can style it up. So we have the nav icons, account, wishlist. Let's have cart next. So I'm just going to create another A element, give this the href of hashtag cart, and then fa shopping cart size 20. And again, let's put in a span, class name badge, and we can put 2 just to be different. Okay, of course, once again, make sure to add this dynamically if you choose to build this out. Okay, and wonderful. So let's move on. Now let's do the navigation menu bar. So the navigation menu bar, so after 1, 2 divs, so right in here, I'm going to create a nav. And in here, well, we're going to have some list items. However, first I'm going to give this a class name, just like so. And this is just going to be navbar, like that. In here, we are going to have an unordered list. I've already pre-made it to save you from making mistakes, but essentially this is an order list for the nav items. We have home, electronics, clothing, home and kitchen, beauty, sports, and deals. They're not going anywhere if you click them. That part, once again, you will have to build out. So that is my unordered list done. Okay, so we've got nav, div, header, and that closes off our header. Now we're just going to do the main content area. So main, just like that. In here, we're going to have a div. This div is going to have the class name of hero. Then we're going to create a div with the class name of container. And I'm simply just going to put in an H1 element that says summer sale is live, and then get up to 50% off on all selected items, limited offer, and simply a button, which once again won't do anything. It's just for show for now. So that is our main section. Let's finish off with the footer section. So footer, let's create a div. This is going to have the class name of container. I'm just going to give this the class name of footer as well. Of course, you don't have to do this. You could just pick it out by the element. It really depends how you like to work. And in this container, well, I'm going to have another div. This is going to have the class name of footer content. I'm going to create another div. This is going to have the class name of footer column. And here we're going to have an H3 element that just says shop. Another unordered list, and that is 1. And we're going to do 4 of these total. So each footer column, perhaps you just want to copy that. And I'm just going to paste in another one and paste in another one and paste in another one. So that is 4 total. Okay, so these 4 footer columns, the first one is shop. This one is going to be customer service, making sure to spell customer correctly. And then customer service consists of contact us. Then we have FAQs. Then we have shipping policy, just like that. Returns and exchanges, order, tracking. Okay, now we have about us. So I'm just going to change this to say about us. Change this to say our story. Then we have blog, just like so. Careers, press, sustainability. And finally, connect with us. So connect with us, Facebook, Instagram, Twitter, Pinterest, and YouTube. Okay, and finally, I'm just going to put in the copyright notice. So after this div right here, I'm going to create a div, and this is going to have class name copyright, spelled like that. And I'm just going to use the copyright symbol, dynamic year, and the company name. So there we go, that is it. And of course, we also need to put in our actual chat widget. So after the footer right here, I'm just going to put in the chat widget, just like so. Great. So this is going to be a floating chat button window. So this is looking good. We can now uncomment this out, making sure this is in quote marks. While we are here, let's also correct search bar to be like that. And import React icons. So I'm just going to go ahead and get this, do npm I and React icons, and wait for that to do its thing. Wonderful. Okay, we are done with this page. We are done with this page. One thing we do need to do is just delete report web vitals, as we're not using that. Ta-da, there we go. And now we also need to create the chat widget. So in components, I'm going to create a new file called chatwidget.js. There we go. And I'm just going to shut that down for now. Okay, so now let's work on the chat widget. So we're going to import useState, useEffects, and useRef from React, as we are going to use those in order to essentially send messages to our backend and receive messages. We're going to import some icons as well. And of course, let's write our chat widget. So let's create the component chat widget just like so. And I'm just going to export default chat widget. Okay, great. Of course, I'm just going to return something. So let's go ahead and return a div. And the class name is going to be widget container. And then we're going to essentially check if it is open. If the variable open is true, then we're going to add the string open, otherwise nothing. And that's really it. Okay, so if I just go ahead and define const is open equals true, ta-da, that's what our site looks like at the moment. Now, I will be adding some styling to this, so maybe let's quickly do that now. What we're going to do is have everything with box sizing and margin padding as 0. The body, I'm going to have a font family, a line height, a color of text, and a background color. Then the app itself. So there we go. The app itself is going to have a min height and display flex with flex direction column. And then I'm going to move on to the e-commerce store styles, as we've done that page. And for that, the container is going to have a max width, margin, and padding. The header, I'm really not focusing too much on the styling of this, as this is not a styling tutorial, so I'm just quickly showing you, but please do slow this down if you need. We're going to style the top bar as well. The logo is simply just going to have a different color text and font weight and font size. The search bar, of course, we're going to pad that out and align the items using Flexbox. We're going to also style the input that lives inside the search bar, as well as the button that lives inside the search bar. The nav icons will, of course, also be slightly styled using Flexbox. And the A elements inside the nav icons, again, we're just going to change the color and position of that. Now, any item with the class name or badge that lives inside the nav icons will also be styled. The nav bar itself, well, we're just going to use Flexbox on that and add a border top. Any unordered lists that lives inside the nav bar will also be styled, as well as each list item very subtly. We're just going to change the margin. And every A element that lives inside the nav bar, we're going to change the color as well as mess around the fonts a bit and some padding. Now, on hover of the nav bar, we're just going to change the color of text. And then same for if the A element is active. Let's go ahead and style up the footer content, the footer column, the unordered lists in the footer column, the footer column list items, the footer column A element on hover, and the copyright text. Phew! So that should mean that this is what our site looks like at the moment. Wow, it really does look so different. Just the buttons next. So let's grab the hero section so that that gets applied. Let's style the H1 element in that too. Style the paragraph element. Style the button and the button on hover. Phew! And ta-da! That looks so much better as the hero section. I love it. This is looking good. I'm also going to add the styling for the chat widget just while we are here. So perhaps let's do it under the app. I'm just going to do chat widget styles. So the whole chat widget container, which we have just added, also when it is open, it should have this styling. We also are going to add soon a chat button. So that is the styling for the button. We're going to have a hover styling as well. So when we hover over that button, we're also going to add a chat header. So that should be styled a little bit differently with a linear gradient. A chat title, which is just us simply messing around with the spacing. We're going to style the H3 element in that too. We're also going to style the close button for the chat, as well as the chat messages, an individual message, a message from the agent, and the message from us. Okay? And finally, we have the chat input container, so where we put our chat, where we type that in, and the message input as well. Now the message input, if it is in focus, we're just going to change the border color to be this blue. We're also going to have a send button to send messages, and of course as a button we're going to add a hover effect as well. And if it is disabled, we're going to change the background color of it and not allow cursors on it either. Great. So styling is now done. Phew. Again, please feel free to take that from the code supplied below. Let's carry on with the chat widget. Okay, so if is open is true, and we can see the chat widget well. Let's have a div. I'm going to give this the class name of chat header, another div. This is going to have the class name of chat title. We're going to use a robot icon, so far robot, and then just an H3 element that says shop assistant, just like so. Great. Now let's add the close button. So this is just simply a button, and we're going to put for times as the icon. The class name of this is going to be the close button, and then we're going to add an on click, and this is going to toggle chat, which we are yet to define. Great. Now here the message container is going to go. So I'm just going to create a div. Let's give this the class name of chat messages. Let's actually get all our messages. So messages map message box index. We're going to create a div with a closing div and give this the key, which is going to be unique, and we're just going to use the index value for that. And in here, we're going to have a message bubble with conditional CSS for styling. So there we go. If the message is from agent, add the class name of message bot, which we created. Otherwise, add the class of message user. So essentially, that will change based on whatever message we get. Great. And of course, we need a closing tag. And in here, I'm simply just going to put the actual message text. Wonderful. So there we go. That's what it looks like. I can put this on 2 lines if you need. Okay, great. Now outside of this, I'm going to create an invisible div at the bottom for auto scroll reference. So this just could be a self-closing div, and I'm going to put ref message end ref, which we are yet to define. Okay, now let's work on the input. So I'm going to create a form. Let's give this the class name of chat input container. And it's going to have an on submit, which I'm yet to define. It's going to be handle message. Great. And in here, we're going to have an in output that looks like this. It's going to have the type of text, class, name, message, input, placeholder, text, type your message, ... value is going to be input value, and the onChange is going to be handle input change. So that is the whole input. Now we're going to have a button, and this button is going to have the type of submit, class name, send button, and then disabled. Well, we're going to check if the input value trim equals an empty string. So disable if input is empty or white space. Great. And in here, we're just going to put an icon. So far paper plane to send size 16, just like so. Great. Okay, so that's all if it's open. Otherwise, if it's not, I'm just going to create another button. Okay, but this time the button, let's give it the class name of chat button. This will open up the chat. So on click, we're going to toggle chat again, and let's put in an icon. This time it's going to be far comment dots. Great, just like that. So that actually probably should be after here. There we go. Wonderful. I'm happy with that. Okay, so now let's get to writing some logic and defining all these things that we wrote. So we're going to have to set some things to state. So the const is open. We defined it as true here. We can do it with state. So same for messages. So false, I'm assigning that to the const is open. And if we want to change it, we use set is open to change it. Same for messages. Messages is currently an empty string because we've set that using use state. And if we want to change it, we use set messages. So same for input value. It's going to start off as an empty string. Same for thread ID. It's going to start off as just null. And messages and ref, well, use ref is going to be null. So that is the reference that we wrote to reference the bottom of messages container for auto scrolling. Now we're going to use the use effect hook and just pass through an empty array for now. This effect hook is going to show the initial greeting when chat is first opened. So if is open is true and messages length equals 0, const initial messages equals, and we're going to write an array. We're going to have the greeting text of this, and we're going to create an object which has the greeting text of this, and is agent true. So we're kind of saying that this is from the agent. Even though it's technically not, we want the user to visually see that it's coming from the agent. And then we're going to set that greeting message to the message state. So do it right here. Wonderful. And we want to trigger this use effect if is open changes or the message's length changes. Great. Now we need to write another use effect. So just like that. Once again, let's just start with an empty array. So no dependencies. And this is going to help us auto scroll to the bottom when new messages are added. So by adding this, what I'm actually saying is that we want the behavior to be smooth and we want it to scroll to that messages end ref that we added to the div. And we want this to trigger anytime messages changes. Great. The other function we wrote is toggle chat that we need to define. So let's go ahead and do that. For this, I'm simply going to use setIsOpen, okay, to change the state of open. And you can do so easily like this. So if it's true, change it to false. And if it's false, change it to true. Great. Another function that we need to define is handle input change, just like so. So handle input change is going to be the function to handle changes in the input field. And we need to pass through the event and set input value. So again, we're going to change the value using the event target value. So whatever we type in that input will be saved to state. Great. So wonderful. I'm just going to console log out the messages for debugging purposes. So what they are like currently, obviously at the moment, it will just be the greeting message, but we want to write a function to actually send user messages and get the AI response. So now I'm going to do that. Const handle send message equals, and once again, we're going to pass through event. This is also an async function. We're going to prevent the default form submission behavior, which is the page refreshing. I'm just going to console log the input value so we know what is going on. And I'm going to create a message in the same format that we did above. So once again, it's going to be an object, which is going to take text, which in this case is going to be the input value. So whatever we write into the input is agent is going to be false. As we are not the agent, we are us. Okay, so that's what our message is going to look like. And we're going to add that user message to the messages array using the spread operator. So at the moment, it's just a greeting message. But thanks to this, it will be whatever we type into the input as well. Great. So we're going to save that to state and then set the input value to be an empty string again, so it clears it visually for the user. Wonderful. So handle send message should be the same as it's written here. This is handle message, so maybe just change that to be exactly the same. And this should say on submit. This should say messages end ref. Okay, great. So now if we click on here, it opens. Here's the message. And if we close, it shuts and opens again. And if we inspect this and view our console log, ta-da! So amazing. Hello, I'm your shopping assistant. How can I help you? So that is the object is agent true. So like I said, this is mimicking being the agent, even though this technically didn't come from our agent. And if I type something like, hello, do you have any tables? This also gets updated, as you will see here. So, hello, I'm your shopping assistant. And if I send this, there is now 2 in here. So I'm collecting messages. Hi, hi. Now there is 3. Okay, so nice. We're collecting all these messages together. Now let's actually work on sending stuff back and forth to our backend. So let's do it. So still in our handle send messages function, after set input value, so after us clearing that input so we can start fresh, I'm going to determine the API endpoint. So we're going to use an existing thread if available, otherwise create a new chat. And we do so like this. So if a thread ID exists, then we go to this endpoint, which we wrote in our backend. Otherwise, start a new chat by going to this endpoint. There's no thread ID so far, so it will start a new chat. Okay, so now let's try. And of course, catch error, console log error. And we're going to make an HTTP post request to the backend API. So const response, we're going to get that response. First, we're going to await fetch endpoint, so whichever one came back from here. Method, as we said, is going to be post. Headers, we're going to put content type application JSON. Body, in the body, we're going to do JSON stringify and just send through the message that we are typing, so the input value. And if response, okay, so we're going to check if response status indicates success, so the 200 to 299 range. Make sure to spell response correctly. So if it's not okay, we throw the error. And then also the response status, so we know which error it is. Great. So now we're going to pass the JSON response from the server, so whatever's come back to us, we're going to do that here. And we're going to console log success and the actual data that came back to us. Now we're going to create a message object, so it has to fit the ones that we have been working with so far in this file. Agent response. So it's simply like this. It has text, and I'm going to get the data response because I know that's what the object looks like. Response is agent. Well, we know it's true because it's coming back from the agent response. And thread ID. If this exists, we're going to add it. So thread ID, and it should because, you know, it's a chat. Okay, so the thread ID only comes back if it's coming back from our backend. Otherwise, you know, if it's from our front end, we don't have that. Now let's go ahead and add this agent response to our messages. So we're getting all our previous messages and the agent response, and we're setting them to the messages in state. Next, it's also set the thread ID to state, so we can use it. And I'm just going to console log out all the messages so we can see. Great. So I think this is looking good. There's not much really to say here, so I'm just going to do that. Wonderful. So let's give this a spin, shall we? Let's refresh. Do you have any tables? Question mark. Ta-da! That's amazing. So we've done it. We created this cool AI agent. I hope this was useful for you. If you have any questions, please do comment below. Once again, this is what we have built. I'm super proud. I hope you've made it this far. And of course, please do share your project with me. I'd love for you to tag me so I can see what you have built, even if it's just a picture. Get creating, and I'll see you again soon.